Number 6, we have a fraction equal to another fraction. And I told you, when you have that, one single fraction in one side of the equal sign and another single fraction in the other side of the equal sign, you can cross multiply. Then we're going to do this. This times this is equals to this and this. It's up to you how you do it. You can do that one first, you can do this one first, that doesn't make a difference. 2x minus 3 times 1 is equals to 3 times 5x, 5 minus 2x. Then we multiply 1 times 2x, 1 times negative 3. Right? That gives me 2x minus 3 equals to 15 minus 6x. Okay? After this, we have to combine, well, we have to solve this equation. We have x in both parts of the equal sign, so we're going to put the x's together in one side, the numbers in the other side. So let's move in, the 1 is negative. You always move the lowest one, because that way you never have to deal with negatives. See? So try to move this one to the side. Because I move the 2x to the side and I get negative 8x. So it's easier to do it. Plus 6x. I have 8x minus 3 equals to 15. This is cancelled. Now add 3 in both parts. 8x equals to 18. Divide by 8. X is 9 divided by 4, right? X equals 9 over 4. That's the solution we're getting. Well, we're not going to highlight yet until we check for extreme solutions. Remember, in the test, you have one of these problems, or 2, and you have to check, and checking is part of it's half of the credit of the problem, okay? So we're getting 9/4 as solution, so I have to rewrite the original one, and I'm going to change, instead of x, I'm going to write 9/4. So this is what I get. 3 over, is the checking part, x equals 9 over 4. 3 times over 2 times 9 over 4 minus 3 is equals to 1 over 5 minus 2x. 5 minus 2, and we say the x is 9/4. See, sometimes this happens. Sometimes the checking part is more work than solving the equation. Like, especially when you have negatives in rational equations or radical equations. So, but it's a good practice. Look at it that way. It's a good practice. So we're going to, this is a complex fraction, so we went to that yesterday. Solve the denominator first and keep working, bringing down everything. So this is going to be 3 over, put 1 underneath. Never multiply 2 times 9 and 2 times 4. No. You put 1 underneath and it's you multiply across. 18/4 minus 3 equals to 1 over 5 minus 18/4. Then we have to subtract these fractions. One is a whole number and the other one is a fraction. So I am going to do this. 3 over 18/4 minus 3 over 1. And this one is 1 over 5 minus 5 over 1 minus 18/4. Since I have to subtract this, I need to have the same denominator multiplied by 4. This one by 4. So I have 3 over 18/4 minus 12 fourths equals to 1 over 20 fourths minus 18 fourths. Then I have this, keep working, 3 over, this is going to be 18 minus 12 is 6 fourths, right? Same denominator. Is that equals to 1 over 2 fourths? See, maybe. We have to, since this is a complex fraction, the fraction on the bottom is complete, is 6 fourths. The one on the top is incomplete, so you put one underneath to have a fraction of another fraction and use that technique that we learned yesterday. Put the one underneath here. You go 3 times 4, the answer goes on top, is 12. And then 1 times 6, the answer goes on the bottom, is 6. 1 times 4 is 4 over 2. I'm repeating the process. It's no problem. So we have then 2 equals 2. That means 9 fourths is a good answer. Here you go, 9 fourths. Highlight 9 fourths because it's a good answer. Okay, like I said, the checking part is going to be, it's going to give you work.
Can you just go down, Miss?